Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 7, Section 3. And in this video we're going to be taking a look at another example of how to find slope or rate of change. In the last video, when we found rate of change or slope, we were using a line that went directly through the origin. There's a special kind of name for that line, and there's some special properties about that line. You may have kind of began to notice some of those properties in the last video if you're paying attention. But the average line does not go through the origin. Most lines do not go through the origin. So today, I am going to show you how to find rate of change on a line that does not go through the origin. So the line that we're going to be taking a look at connects these 2 points here. So you can see that this line does not go through the origin, which is right in the middle there. And we're going to call this point A and point B. Now, if I were to take the ordered pair of points A and B, point A has an x-coordinate of -1 because I have to move left one space, and a y-coordinate of +1 because I'm moving up one. And remember, the x-coordinate's always on the left, y-coordinate's on the right. Point B has an x-coordinate of +2 and a y-coordinate of +2. Okay? Now remember, there are two ways that you can find slope or rate of change. You can either manually find it by counting spaces on the graph. Okay? Now that doesn't always work well depending on what the increments of the graph are and how far apart the points are. And sometimes you're not even going to have a graph to help you out when you're trying to find rate of change or slope. Sometimes you'll just have an equation. And to find slope using an equation, you would definitely need to use the second method I talked about in the previous video, where you use the slope formula or the rate of change formula, which is y1 minus y2 over x1 minus x2. This will always work without fail. Whether you have an equation, whether you have two ordered pair, or a graph with a couple of points on it, you can always use this to find your slope or rate of change, and it will guarantee you the correct answer. But I intentionally made a problem where we could do it with either method. So let's take a look at the graph and use method 1 for a moment, where we find the slope manually. So remember, slope or rate of change is the vertical change, so the up and down change. When I move from point A to point B, how far up or down am I moving? Going from point A to point B, I have to move up 1. So first part of my rate of change is 1. I'm going up 1. Now, so rate of change is the change in vertical distance over, that's why I put the fraction bar, over the change in horizontal distance. Horizontal is that left to right distance. How far from A to B did I have to travel along the x-axis? In this case, I went up 1, so my vertical change was 1. And I went right 1, 2, 3. So I have a horizontal change of 3 spaces. There are 3 horizontal spaces between A and B. So if I show the vertical change like this, the horizontal change with this line, you can actually see it makes a right triangle. So when you draw in the slope or the rate of change, it will always make a right triangle. And there is something special you can do with that. We'll get to that in some later chapters. Nothing to worry about right now, but it is something to take note of. Just observe that, take a note, lock it away in the back of your memory. So the slope of this line would be 1 over 3. So for every increase of 1 in the vertical distance, you have an increase of 3 in the horizontal distance. Remember, rate of change is how the change in one quantity affects the change in another. In this case, it's the vertical change is affecting the horizontal change. So when the vertical changes by 1 or increases by 1, the horizontal is increasing by 3. Now, you could also use method 2 to solve this as well, using the slope formula, or the rate of change formula, whatever you want to call it. This requires you to figure out what the ordered pairs of A and B are. A lot of times that'll be given to you, okay? And we did that earlier, up here. And then you need to plug it in. Remember, these little numbers down here they're nothing more than labels and directions. This is telling you the 1 and the 2 up top are telling you that these y's are not necessarily the same number. The two 1s here on the x and the y are telling you that this y and this x come from the same ordered pair. So, for example, if I am going to plug in the y coordinate of b for y1, then the x coordinate of b has to go in for x1. So here you can see I have point B. If I'm going to plug in the y coordinate of A for y2, then the x coordinate of A has to go right underneath it in x2. Okay? So what it would look like, if I were to set this up in the formula, I'm going to take the y coordinate of B over the x coordinate of B, minus the y coordinate of A, minus the y coordinate of B, the x coordinate of A. So the y coordinate of A, the x coordinate of A. Okay, they're right on top of each other. Make sure you're putting the y coordinates on top, x coordinates on bottom. Okay. As usual, I'm going to use keep, flip, change because I have subtraction there. So keep the number on the left, flip subtraction to addition, change the sign. Same thing on bottom. So 2 plus negative 1 gets me 1. 2 plus 1 gets me 3. You can see that both methods got me the same slope or the same rate of change. Okay? And as I said before, you can use that rate of change or slope to find other points on your line. So if I go up 1 over 3 from A to B, it'll get me from point A to B. If I want to find a third point, I can start at B and go up 1 over 3. And there's a third point. And I'm still on my line. So that's just another example showing you how to find slope. And I'm showing it to you with an example of a line that does not go through the origin. As you can see, the ordered pairs themselves help me get to the slope, but they didn't represent the slope itself. Remember, when the line goes right through the origin, every ordered pair or every point on that line actually contains a slope in their ordered pairs. But again, that's something we'll talk about in the next section. So tune in for Chapter 7, Section 4.